Welcome to another Zadita webinar. No connection, no problem. We'll give everybody just a couple of minutes to get in, and we'll get going shortly here. Usually there's a huge burst at like 1 after. We have quite a few people, but for those just joining, give just a moment or two for a couple more. Let's say about 30 more seconds, we'll get it going. There's still people filing in, as well as their AI note-taking assistants. All right, let's get this going. So welcome to another Zadita technical webinar. Today we're covering no connection, no problem, managing air-gapped and remote edge infrastructure. I really like this topic. We know that Zadita is the leader in management and orchestration for the distributed edge. And it's so common, it's such a big part of that, to have air-gapped environments, whether it's for connectivity purposes, technical reasons, these are far-flung locations, or more commonly for security reasons, right? This is an air-gapped environment, doesn't touch the internet, it is as secure as we can make it. These environments are a huge part of distributed edge. And so today, to talk to you about this, we have a couple of great presenters. First, we have Daniel Dirksen, who's Director of Product Management for Zadita. He has his hands pretty deep in this and has a lot to say on it. It's fantastic. And we have Sergio Santos, who's an account solutions architect, very senior at Zadita, has dealt with this directly. We'll actually see a demo of using Edge View today. It'll be fantastic. For questions during the presentation, please go ahead and put those in the Q&A. At the end of the session, I'll read them all out to Daniel and Sergio, and they will get them answered for you. All right, so let's get this going. Daniel, please take it away.
Thank you, Rob, and good morning, good afternoon, good evening to everybody on the call today. Very excited to talk to you about this topic. Before we talk about no connection, no problem, let me just talk a little bit more broadly on what we're seeing happening in the edge space. So first of all, why are we building all this infrastructure? Well, clearly we're building edge infrastructure because we need to run application in the edge. That is the sort of fundamental reason why we're putting all this stuff together. When you look at edge application stacks, we clearly see an evolution from left-hand side monolithic architectures, typically Windows-style apps or Windows-based apps, to what is now predominantly containerized applications, towards, on the right-hand side of the picture, the adoption of Edge AI or the rollout of Edge AI use cases in customers' infrastructures. And in terms of the actual adoption, it's clear that in IT and cloud world, we've seen migrations to containerized workloads already for a while. Definitely in OT environments, applications are generally have been around for a longer period of time. There's given the impact of change, a more conservative approach to how you're rolling out applications and how often you refresh things. So we definitely see a transition there from monoliths to more containerized type of approaches, and whether that's Docker style or Kubernetes style, that's yet another discussion. But at least in terms of the direction, we're definitely seeing those trends. On the adoption of AI at the edge, This is an interesting topic. We see more and more machine vision use cases, but also things like vibration monitoring, audio monitoring use cases, applying some fast Fourier transformations to analyze the spectrum of audio to figure out, is there something wrong with the machine? Is there some predictive maintenance type of activity that we need to schedule because we hear wear and tear on some physical infrastructure. And so obviously that's exciting in general, but it also ties quite to our topic of today, because as we're moving to these kind of AI-driven or AI model-powered application stacks, the move of iterating, or the need for iterating over these stacks also goes up, right? Obviously, there's a lot of development in that space, both from an application perspective as well as from a model perspective. And yeah, if you want to iterate over models, then clearly you need some mechanism of getting those new models or those new containers deployed on your edge infrastructure, which clearly requires some level of connectivity, right? So having said all that, let's just do a quick recap on some of the challenges that we typically see in edge environments, just to level set on it. There's a couple of things that make the edge kind of the edge or specific. One is the fact that when we talk about edge, we talk about distributed edge, and these we categorize as devices that are deployed outside of traditional data center environments, which from a security perspective obviously means that you no longer have physical security. There's no batched entry, there's no security guy in front of the data center. These are devices that sit in your business process, whether that's a store or whether that's in some truck or whether that's on some site. So that has implications on how you build and how you manage, whether that's things like measured boot to make sure you're booting the software that you're expecting to boot, or other forms of security. But clearly that is important, and is even more important in the edge. Scale. So obviously we're talking about deploying in the hundreds or the thousands. So yeah, it's quite common to see people in small use cases to start with, do it yourself type of use cases. It's not that hard to deploy on X number of devices. And when X is small, yeah, that's probably true, right? Get some OpenVPN, run some Ansible playbook, and probably there's a bunch of things you can functionally do. But once you get into the hundreds or the thousands, well, now it becomes a pain, right? Now it becomes a lot harder to maintain, to make sure things are consistent, to make sure that you have a mechanism to automatically roll back in case of a failure. Maybe you're changing something and it affects the network connectivity. Well, if that fails, you just disconnected your entire fleet. So some automatic way of recovering those things. So once you start adding all these things together, life becomes a lot harder to make this scalable. Hardware and software diversity. So that's also something that I think fits or is a characterization of edge very, very much. In data center, you generally have quite unified type of hardware. Whatever is the server that provides the best compute scale and density for the problem you're trying to solve. Usually it's quite unified in terms of what those servers look like. Yes, of course, there's generational differences, but within a generation, if this is the form factor that fits for you, then you usually buy a whole bunch of them. In the edge, life is a bit more complicated, right? Things are generally deployed for a much longer period of time because refreshing things requires a truck roll, and that's expensive. So you typically end up with different generations of hardware out in the field. So that has implications on manageability. And also from a software perspective, as we have already touched on, there's evolutions in software stack, whether that's VMs to containers to Kubernetes to edge AI. Those things have implications on how you manage and what you can manage. But also, when you think about software diversity, there is a set of capabilities around the hardware that you're deploying on. Today it's x86, tomorrow it's ARM, the day after it's some Jetson powered device, NVIDIA Jetson powered device. So all those things have impact, and you, from a solution perspective, obviously need to cater to those. Then finally, unique connectivity needs, right? And Rob already alluded to some of those angles. There's a multitude of different things to discuss in this space, and that's obviously the reason why we're having this webinar. So let's dive into the connectivity topic. So first of all, why do we need connectivity to the edge? Well, in my mind, there's kind of two problems we need to solve. We're deploying applications out in the edge because they're generating business data for us. And that business data, one way or another, needs to be translated into insights that ultimately allow us to do our business better, right? Whatever that means. So it's ultimately about, getting those insights to, some central location where you can actually do something with that information. And I already touched on the AI ML model lifecycle loop. So this will become more important as we go forward because iterating over those models will be important to basically get the best performing app out there. If it's an old model, if it's an old set of training data that is effectively implemented there, then obviously whatever your evolutions are in terms of your model training and fine-tuning, you won't be able to leverage or take advantage of that until you actually have this deployed in the field, right? So that's important. We need to have that connectivity. Then the second bucket of reasons why we need connectivity is because, well, we're deploying all these things out there, but we also need to operationalize it. We need some way of orchestrating it. So obviously having some management infrastructure centrally, it reduces the overhead versus having to go to all these different locations and sites to manage their things one by one, right? What it also brings is deployment consistency. So there's nothing worse than having 3,000 devices deployed out there, but not quite being sure how each of those devices is configured. We want speed of change. So when we have a new version of our app, or we need to adjust in the business in terms of deploying new types of apps, well, we want that to be out there as soon as we can because it will start contributing to our business process. So speed of change is obviously important. And then finally, both deployment consistency and speed of change are also elements that will ultimately help to ensure we keep a proper security posture, right? So being able to roll out updates, whether that's on the OS side or whether that's on the application stack side, it's important that once we find out that there is a vulnerability to consider, that we can actually roll out updates to the stack to mitigate those vulnerabilities. So as I said, kind of inside the app side of the house and operationally, how do I manage this infrastructure? Those are reasons why we need connectivity. So you may agree, hopefully you're agreeing with me that, yeah, we need connectivity between the actual edge infrastructure and the more centralized stack that manages that infrastructure and the stack that is managing my application information. But you can have quite different views on between which endpoints I need that connectivity. And that ultimately comes down to where is my management infrastructure versus the edge devices. The edge devices clearly are out there, right? They are sitting in wherever your primary business process is, but where you put the management infrastructure, you can clearly have a number of different views on. So one way to look at this is centralized versus distributed, right? And on the left-hand side of the scale, we put everything super centralized. I have a single entity that manages all these edge devices. And then on the other side of the scale, I fully distribute my management infrastructure. Clearly, it will be operating on a smaller amount of devices, but it's something that you can obviously do. And then there's all shades of gray in between. So if I bring that back to the two topics we just looked at the previous slide, insights to begin with, obviously putting that infrastructure centrally, what it ensures is you have global insight, right? If you have one place where you're collecting that app stack information, but also managing the actual fleets, it gives you global insight in what is happening. Whereas if I fully distribute this management infrastructure, then obviously, yeah, we'll still get those insights, but collecting those or making them actionable is a lot harder, and it becomes scattered insights. When I think about this from like an orchestration perspective, one way to look at this is when this is super centralized, it effectively becomes a fleet management type of capability. Whereas if I fully distribute this, and if I go into the extreme where my management is distributed all the way sitting next to the node, or maybe even part of the node, well, ultimately that becomes like node management, right? There is no fleet anymore when it's distributed one-to-one to the actual node you're trying to manage. Looking at these scales, in my mind, and hopefully in your mind, the left-hand side of this picture is the desired position, right? Like we obviously all want global insights. More information centralized will give us an easier way of consuming that. And from a management perspective, being able to manage fleets is obviously a lot more comfortable and a lot more optimized than doing this in many small sets of fleets or even down to node management. Now there's a but, clearly, because this may be desirable from those angles, but there may be practical things kind of getting in the way. You may not have connectivity to a central location, right? It's getting a little bit less of a problem, I would say, from a pure technical perspective, with more and more solutions like 5G and Starlink to become easier available and cheaper as well. But that doesn't mean that that is always possible. You may not have reach. You may not have, you're inside like a Faraday cage type of deployment method. Maybe the business case of whatever problem you're solving doesn't justify investing that amount of money for that connectivity. So it may still be an issue, but I would say, more typical reason why this is a challenge, it's because of the regulatory environment in which use cases are operating. And if you have very stringent security requirements, then obviously bringing everything back to some centralized location may be a problem. So what I wanted to do in this slide is kind of think about this edge connectivity as a spectrum, and I tried to put a few scenarios and use cases on this spectrum. I realized it's not every permutation, but these are some other things that we're seeing. Where the left-hand side of the picture is obviously looking at it from a centralized perspective, and in some sense, the most centralized way to look at this is from a SaaS perspective. Somebody is offering you some central service to manage this. And from a connectivity perspective, the left-hand side of the picture is I'm always connected, right? Whereas on the right-hand side of the picture, the other like fully distributed, disconnected type of scenario would be I have some air-gapped infrastructure, and I'm managing this through some on-prem solution, right? That is co-located with that air-gapped set of devices. So those are kind of the extremes. And what I wanted to do is talk you through some intermediate steps and some of the things that we're seeing there. So there's kind of two considerations I wanted to point out. One is a set of operational considerations. So when I'm on the left-hand side of the picture, SaaS always connected. One case that we see quite often is, well, yeah, in principle, I have connectivity. However, sometimes I don't. So it's a satellite, it's cellular. Sometimes I'm in a gap, and now what do I do, right? So from my perspective, I think this is mostly more of an implementation impact. Like, how do you achieve this centralized management? You need to assume that you may not always be able to talk to all devices. You need something that is eventually consistent. You need to somehow make sure that people didn't tamper with infrastructure while it was disconnected. So there's implications for sure, but I would argue that it's mostly in the way that you're doing things, not so much in the architectural approach of how you're putting together the overall solution space. Now, there's another bucket of considerations that I dubbed policy considerations, which are really around security and safety and confidentiality, which usually follow from a breach of security. So these things are obviously important in regulated environments where they need special attention because of the type of business that we're talking about. But these tend to have more architectural impact, right? So let me talk through a few permutations of solutions that are driven by those considerations and how you can address them. So the first, from left to right scenario I wanted to touch on is we see cases where people want to control something or interact with something on the factory floor, but there is obviously, for good reasons, restrictions in terms of what type of infrastructure can talk to things on the factory floor. And for those of you in the OT space, there is this Purdue security model, and there's a few different levels. And the lower you get into the level of the Purdue model, the more stringent the requirements become, right? So, one way of dealing with, hey, we cannot have external connectivity to our factory floor, maybe to deal with solutions such as data diodes. So a data diode is a device that allows communication only in one direction. And this is a bit of a special case. It doesn't really have something to do with how you talk to the edge device. It's more to do with how the edge device talks to the actual factory floor. So we have a number of OT use cases where people put a data diode between the application stack running on the edge node and the actual things that it's collecting information from. So this works. This is a really strong way of separating things. There's also limitations. You can receive things from the factory floor, but you cannot send things to the factory floor in this specific case. So if this is about observability, if this is about predictive maintenance type of use cases, that may be perfectly valid. If you want to control something that sits on the factory floor, then obviously the data diode needs to have communication in both directions, which does not make that like a sufficient solution to operationalize that type of use case, right? But it clearly is a valid approach to separating connectivity between the infrastructure and the factory floor. Then the next bucket of things I wanted to touch on is self-hosted, right? So if the premise is that, well, I like some of the properties of your wonderful SaaS, but we cannot have this, our infrastructure connect to the public internet to reach your SaaS. There are obviously different permutations of self-hosting things. So in our speak, take our Zadida cloud and state, for example, in a private cloud, or in an on-prem solution, right? And a private cloud in this case, it could be a private cloud instance that is still hosted on public offers, right? And we actually have an example of that, and I'll talk a little bit more about it in just a moment. So in this kind of like bucket of solutions, basically you're taking that management infrastructure and somehow put it into an environment where you have more control. Okay. Then on the right-hand side of the spectrum, as I said, you can obviously have something completely air-gapped and on-prem. So in our speak, take Zadida Cloud, somehow put it into like an on-prem package, deploy it somewhere, and like operate it from there. So you can obviously do that. I'll talk a little bit more about operational implications, but one of the, I would say, solutions on the spectrum is on-prem plus break glass, right? So you can have a fully disconnected type of infrastructure, but periodically allow breaking of glass, so to say, where you temporarily breach connectivity between that isolated solution to some external access. And that typically can be for troubleshooting reasons, like you need like third line, fourth line support to do something, or it can be for lifecycle type of events, right? So point on this slide basically is that, hey, there is a spectrum of connectivity options, depending on what is your, what is the business environment in which you're operating. There might be different types of solutions that all have their own operational implications that may be fit for that use case. So instead of just talking about it in sort of abstract terms, I wanted to just talk you through 3 use cases that we've been working on with customers and prospects, and that all relates to non-connected or not fully connected type of edge use cases. So the first case on the screen here is a semi-air-gapped set of small sites. And this customer, they're actually building industrial infrastructure for their end customers. And they do so in a build, operate, transfer type of manner, which is a quite common thing, I would say, for building big infrastructure. And from an edge node perspective, what they typically do is they deploy 10 to 15 nodes on each of those end customer locations. So it's a relatively modest type of deployment per end customer, but clearly it solves an important problem for them in that industrial infrastructure. As the slide notes, it's variable connectivity availability. And what I mean by that is sometimes they have full connectivity, typically using the build phase of a project. Things to be connected to the internet is not an issue at all. But then as they go into the actual operate and transfer part of their project, customer may have a view on whether they do or do not want to have external connectivity. And sometimes it is, yeah, connectivity is fine. Here are some of the rules of the game, but you can have connectivity. Then we can run in our traditional sense. But sometimes that is a problem, and they only want to open up connectivity in case of trouble, troubleshooting, or lifecycle events. And sometimes they don't want to even do that, right? So what is the potential solution to this problem? For those of you that have been following us, we did a webinar probably a year ago on something we call Edge Sync. Sergio is going to demo that a little bit later in a lot more detail. But the basic premise behind Edge Sync is illustrated in this picture. The idea is that I have Zadida Cloud. I have a SaaS-based solution. And I have some infrastructure that sits on a site. So our normal way of dealing with or interacting with devices is you configure something in the cloud. That ultimately results in some new device configuration being generated. And then the device periodically checks in with the cloud and says, hey, I'm device X, Y, and Z. Do you have a new config? It's like, yep, here's your new config. And the device downloads the config and implements whatever the changes are, right? So that's the regular way of working. So in Edge Sync, the idea is very similar. We continue to configure things in the cloud. That will result in some configuration change for one or more devices. But obviously, devices in this case are no longer able to access the cloud. They're in an air-gapped environment. So what we're offering is a mechanism to basically retrieve the configuration assets from the cloud and use whatever out-of-bound mechanism that you have to transfer these configuration assets into the air-gapped location. And we have a tool, a service there called Edge Sync that basically takes those artifacts and then pushes them into the devices that you may have in that location. So basically what Edge Sync is implementing is a manual way of transferring, or a out-of-band way, I should really say. It doesn't necessarily have to be manual, but an out-of-band way of transferring a config from the cloud into a location, right? So this is what it looks like for that customer. So basically, their operational model is I deploy Edge Sync for all customers, and sometimes it's as a backup, right? You see it on the right-hand side of my picture. So when the end customer is connected, yeah, it's sitting there, but it's really not, in use because, well, we have connection. It sits there to deal with, the other potential evolutions of that connectivity. Customer says, well, yes, we were fine before, but, due to new threats that we see, we actually need to move this to a different model. And one of the models is on demand, where customer provides a jump host, and they can open up access to that jump host. Our customer can push their app stack, their app images, their configuration into that jump host, and from there into Edge Sync, and then roll out those changes. Or in case their end customer really doesn't want things to be connected, well, then the reality is that a service engineer takes a configuration from zCloud, puts it on a USB, drives to the site, adds it to Edge Sync, and basically roll it out from there, right? So what you see here is a mechanism where you can do fleet management. That's a pretty important thing, right? So you see they're relatively small sites. So doing like an on-prem solution for, like so few sites really becomes super inefficient, and it's not very scalable either, right? If you have hundreds of these end customers, that's a lot of like local instances to take care of. So with Edge Sync, you can keep doing that in the cloud, but operate it in a air-gapped environment. Second scenario is a self-hosted scenario, but with partial access. So this is kind of a two-tier model. So we have our customer, the Zadida customer, who have their own end customer. And in this specific scenario, the end customer, they for regulatory reasons, need to have our solution in their own environment. And in their environment, in this specific case, it is still a public cloud, but it's their tenant in a public cloud. What they are able to do is provide our customer access into, if you like, the northbound side of Zalida Cloud. So our customer can effectively operationalize, manage our solution to their end customer as well as their own, right? Because obviously on top of us, our customer is providing their own application stack. And then you see a dotted line that goes to Zalida. So this is where we can have access to this hosted cloud, if you like, for infra support, lifecycle management, troubleshooting, the things that become a lot harder if you have zero access, because now you need to find alternative ways of getting, assets between left and right of the picture, right? So this is one example of self-hosted with partial access. The third scenario, this is kind of one of the more extreme variants on my spectrum picture from before. So this is a customer, a very large customer that has many sites. And I always talk about site, but the sites in the previous pictures, they were 10 to 15 nodes. We're now talking about sites that have hundreds to thousands of edge nodes, right? So site really in this picture means industrial complex. So this customer is operating in an environment where they can really not have any connectivity. So it really means like an on-prem zCloud type of solution where they have their own staff operationally running things, and where we can periodically support that infrastructure, whether that's lifecycle management events or whether that's like third or fourth line support. But it basically becomes a discussion of physically bringing people to that site or set of sites to support this infrastructure, right? So these are not made up; these are real cases that we're actually currently working on with customers and prospects. So getting to the end of this section. Especially on the self-hosted, there is many shades of gray, as hopefully is clear to you. And I would say that the level of access is ultimately a sliding scale of operational challenges. It's directly proportional to the operational complexities. And so there's a couple of areas that I think get impacted: monitoring, troubleshooting, and maintenance. So if you look at monitoring, if you start doing things in self-hosted on-prem, then clearly you need to monitor yourself. It becomes a local responsibility. So that means integration into local tooling. But it's probably manageable, right? It's not the end of the world. It's a bunch of standard interfaces. So that's something that shouldn't be super hard. But the further we go to the right, the harder it becomes. So troubleshooting, well, clearly you need L1, L2 troubleshooting, locally. Or get some resident engineer to support you. Then we get into, well, okay, maybe it will be great if somebody can take some of those challenges away from me, but is it 8x5? Is it like 7x24? Is it batched on site? So you can start digging deeper and deeper depending on how restrictive you are in terms of what connectivity you provide or what kind of access you provide in general. And then finally, on maintenance side, so maintenance in software obviously means lifecycle management. How do I get new software images deployed? So can you do break class, as we talked about before? Life is a lot easier. If not, you'll have to stand up your own infrastructure to serve assets, right? To serve files, whether that means container registry, whether that means FTP, HTTPS type of infrastructure. And then obviously you need some way of transporting those artifacts to validate that, yes, their hash is correct. So there's a bunch of operational things that go with it. Wrapping from this angle, right? From a Zalida perspective, we can cater to different scenarios. There's a number of things that we have today. Some things are in proof of concept at the moment. I'll circle back on that at the end of the presentation. What we wanted to do next is talk a little bit more about EdgeSync and give you a feel for what it looks like. We did some product development work around a user interface. So I'm going to hand over to Sergio and have him walk you through edge sync in more detail and give you a demo as well. So Sergio, please take it away.
Yeah, thank you, Daniel, for the fantastic intro on the different use cases for disconnected edge computing scenarios. So I'm actually going to focus a bit in edge sync for the first use case that Daniel presented. So where we actually have we have a fleet of devices, relatively small fleet of devices with 10, 15 devices, right? And they might be connected, they might be disconnected from time to time. So we call it this intermittent connectivity, or they might be not connected at all, right? So they were just connected during the commissioning activities, and then we didn't get any more connectivity to the control. So to solve this problem, basically, we need a local infrastructure, right? So you can do a fleet management, and you can solve these three operational challenges that Daniel just mentioned, right? So we have observability, lifecycle management, maintenance of this relatively small fleet of devices, right? So, and for that, instead of deploying a full-blown controller, right, in these locations, right, which can actually be big industrial locations as well, we came up with the Edge Sync, which is essentially an API server endpoint for devices to connect. So it's a low hardware footprint, is quite convenient to install so it's in a form factor of a container, so you can just install it in that remote location, and it can be used basically to do fleet management of all these devices sitting there. So it basically supports this air-gapped or intermittent connectivity, so the devices can be online or can be fully disconnected, and you make sure that the operational model that we have implemented with Edge Sync, that these devices will have always a consistent configuration. There's no split brain. There's no risk to go in that situation where someone made some configuration in the cloud and then the devices are not really up to date. So we make sure that the design is robust enough for those kind of scenarios. So this basically enables us to transition the devices from connected and disconnected. So we make sure that in this case, our cloud controller is always the source of truth. So you make sure that the device will always get the latest configuration, and it can actually transition into disconnected states, right? So, and with this, when the device, of course, is connected, you can always operate it. So either by using a jump host, by collecting the configuration blobs from the main controller, or either transferring those assets offline, right, into the Edge Sync. And of course, Edge Sync, the user can operate it. It provides a HTTP JSON API that we can use to operate and develop automation around it. And we also have a UI, like Daniel mentioned, for it, so that you can easily from a UI monitor the state of our local fleet and also update configurations. And you also can, using the API, we can also collect a bunch of metrics that the device also exposed to the main control, so you can monitor the state of our application stack locally. Okay. So moving forward, the next is essentially, we already saw this diagram. So we have a local Edge Sync infrastructure. As I mentioned, Edge Sync today is developed in a form factor, is delivered as a container. The Edge nodes will connect it to it, but the workflow essentially requires that we need to onboard the Edge node initially in the cloud, and you need to have Edge Sync infrastructure. So the first thing, we need to make sure that we have hardware resources on these sites. So we might have these different industrial plants, and you need basically a compute resource to host the Edge Sync. So we need to make sure that we can just run that Edge Sync container that will delivers this API for the user and for the Edge devices to connect to. And then the second step is basically to onboard or provision the devices. So that's what we call day one. So in day one, essentially, we need to commission these new devices in the field, in this remote location. So we can do it in a central site. We install Eve software, we onboard the device, we declare the device in our cloud tenant. It will essentially get all the Edge Sync configuration endpoints, and then essentially we ship the device into this remote location. We call it air-gapped. So, and then that's when we start day two operation. So that's when essentially then The industrial plant now is no longer under commissioning state, so there's no internet access anymore in that moment. So, and then from there we might need the local operator needs to connect to EdgeSync to monitor the state of its fleet, to check that all the applications are running, are healthy, if you need to reboot applications, if you need to update any application. So all this then will be done through the EdgeSync API or UI, okay? So the next slide we see here is essentially what EdgeSync is delivering, right? So it's basically an API endpoint plus an UI, right? So last year we just had the API, now we are bringing also the UI component. So southbound, you see on the left-hand side of this picture, we see the edge devices or the EVOS. So EdgeSync implements the same API that we have in our controller. So the device will basically use the same API endpoints to grab configuration blobs, to publish information about applications, to publish metrics as well into EdgeSync. And facing the user, so on the right-hand side, sorry, of the picture, you see essentially the API endpoints that is available for the user if you want to develop automation on top of this. So in case we have this jump host, the user can basically develop an automation to automatically grab the latest configuration blob from the controller into jump host and push it in the EdgeSync. Or you can manually get the configuration blobs from the fleet of devices and upload it in the API, or also use the UI that we have here also on the top right corner, okay? So the next slide is essentially an overview on these three different operational dimensions that Daniel also concluded his presentation. So on this monitoring, troubleshooting, and maintenance, and we try to do a comparison what we can do in the cloud in our controller, and what also EdgeSync is enabled locally, right? So when these devices are not fully connected. So regarding the monitoring aspect, of course, in the cloud, we have full device metrics, we have application logs, we have capability actually to integrate this with third-party tools like Splunk to export all these logs and events externally. But while in the EdgeSync, like I mentioned, the device is also publishing all the metrics locally. So we can also collect all the metrics locally. And for that, we can export those metrics using an open telemetry collector, right? So that's something we can also use locally next to the EdgeSync to provide that visibility. So that's also part of my demo in a couple of minutes. Regarding troubleshoot, we also have the capability, of course, from our main controller to have full-blown troubleshoot capabilities. So we can actually remote access the devices, you can remote execute commands, you can collect tarball about the state of all the devices. So this makes sense when, of course, the device is remotely, locally in EdgeSync. We can typically, if you're in the same trusted environment, you can actually check the status of the app directly. Or you can also look to the web UI and you can see if the apps are online, if the devices are online, if there's any error. You can also check the metrics, like I mentioned before, that are exported by the device. And you can also do operational commands, like from the EdgeSync, you can reboot applications, you can reboot the device, we can purge application to restore its initial state as well. And you can also generate the collect info and push it in a local data store as well. Regarding the last pillar here is the maintenance and life cycle of the devices and application stack. So we know that from the controller, you can do everything in the device life cycle. So you can upgrade EVOS into the latest LTS versions. The applications, we can do the same. So in case of EdgeSync on operating locally, we can update, of course, the device and the application stack configuration. So we can just do all the configuration changes directly in our main cloud controller, and then apply that through EdgeSync to our local fleet of devices. So with this, we are avoiding this split brain situation. So eventually, if the device gets connected back to the controller, we make sure that the configuration there is always the latest configuration, right? And if it's not, so it means that we are in this middle of this transition, right, in updating the EdgeSync, so the device will also get the latest configuration. So we make sure that the source of truth is our cloud controller. So the next is essentially to guide you through a demo. So of this disconnected use case, disconnected fleet. So in this case, I have a simple fleet of 2 devices in my edge location. And I also have the edge sync already preloaded there in that location. So you see on the bottom right corner of the slide, so 2 nodes, node 1 and node 2. And you also have the edge sync. Both these 3 elements are connected to a LAN segment, a local LAN segment. And in that LAN segment, we have a gateway. And that gateway also implements a firewall, or there's a firewall next to it. And the connectivity to the internet, to our SAS controller, is actually blocked in that gateway. So the devices cannot get updates, right? So we have, in this case, in this demo, I'll show you an Nginx application running on these 2 devices. And we'll show basically how we can update that application remotely. So the first thing is actually the user will update the configuration of that Nginx application in the cloud. We'll purge the application instances, right? So, and then we'll grab the configuration blobs for these 2 devices, right? And then we'll offline transfer it to another user that is actually in charge of maintaining that location or that factory plant. And that user then can use the UI, right? The EdgeSync UI to upload the configuration blob to the nodes, and the UI will give the capability to select or to which devices to apply the configuration blob. So here you have the fleet management capability, so we can apply it to the entire fleet, or you can just apply it to 1 or 2 nodes. And when that EdgeSync applies the configuration, so automatically the nodes will pull the configuration from the EdgeSync locally, and will implement the configuration changes, and they will report back to the EdgeSync that, okay, the configuration was correctly processed, I'm done with my updates, okay? So essentially the video that I wanted to, of the demo that I recorded, so let me just play it. So we log into our tenant. Actually, I'm going to create the nodes essentially initially. So in the first moment, there's no edge nodes created. So I'm just going to create these 2 edge nodes in a remote location. So I will onboard them initially. They have internet access. So and for this, I'm going to use virtual devices, right, hosted in Proxmox. So now back to the device provisioning in the cloud. So I'm going to declare my first device. So here I'm going to bring the project, and automatically that EdgeSync API endpoint will be inherited. It will be taken from the project definition. So you see it here, the EdgeSync at the bottom, the EdgeSync endpoint that was taken from the project. So right now it's a normal device provisioning. So I will just set the network. I will set the static IP in this case for that device, and we will. So we'll do the same for the second node right now. So again, we'll use the same project that will give us the EdgeSync endpoint automatically. So grabbing the serial numbers from my virtual devices in Proxmox. And okay, so both of my devices now are provisioned in the controller. So you see that EdgeSync endpoint is part of the device configuration. And now we are going to bring up our devices. We'll power on. There's Eve already preloaded, but these devices are not yet activated or onboarded. So and by the way, these devices are running Eve 14. So here we also have a local terminal UI in the device console. So this is basically, we can also have some visibility during the onboarding phase if you're connected directly to the device. So you see now that the device got onboarded, got onboarded in the controller, and you'll also see the state changed here in the controller to online. Okay. Now, as these devices are sitting already, they should be connected to Edge Sync. So I'm going basically now to check my local Edge Sync UI to see actually if the devices connect to the Edge Sync. So this is Edge Sync UI, and here we'll see both devices already online in Edge Sync UI connected. So it means that they are, and you'll see also some metrics in this case, like memory and CPU usage and the IP address of the device. Naturally, there's no applications yet deployed on this device, so the list of applications is empty. So next, what I'm going to do is basically to deploy this Nginx application in these two nodes. So actually deploying at the fleet level. So I'm just going to take a very simple Nginx application from the marketplace. So this application has an environment variable just to customize the HTML. So it will show my name, Sergio, you see here, and it also show the host name of the device, right, where it is running. So now I'm triggering the deployment of this application on the fleet of devices, of these two devices, while they are online. So I just provide the name of the application instance. As this is a bash job, so we'll keep the name to the job to complete, and essentially the application then will go through its normal life cycle of deployment. So and then we'll download the image and we'll put it. And you also see here the local terminal UI that the application is starting. And it comes online. So we also see it running it on the terminal UI. And now in the Edge Sync UI, we should also see the application there. So what I'm going to do is just to test it immediately. So I'm quite anxious to see if it's running. So I'll just connect to the 24th IP of the device. So I see my name. It's running on node 1. I will do the same for the second node, which is IP 25. And it's there as well. So running on node 2. And in the controller, everything looks fine. So this is a normal, fully connected scenario. So in Edge Sync now, we see the list as well of the applications reported by each node. And I'm also going to show the Grafana, like the metrics that I mentioned to you, that is also possible to collect locally. So here's basically the Grafana dashboard. You'll see the application state, it's running, the version of the application, the device CPU, device memory. So this is essentially a very simple dashboard of what you can build locally as well next to the Edge Sync using the reported metrics from the device. Okay. So now what I'm going to do next is to disconnect the devices. So I'm just going to my default gateway of this LAN segment and just block the internet access of these devices, and that will. So devices are still online. So next iteration now they are disconnected. So for both devices. And what I'm going to do now is basically to update my application. So my Nginx application. So now I want to change the application, the name that shows up in the web UI from Sergio to Daniel. So now I'm checking locally that everything keeps running. So although devices are disconnected, so the application stack is running locally, the nodes are still online. So our application still shows the web page. So now is the moment actually to update the application in the marketplace. And here I'm just updating it, the variable to Daniel. And that will trigger the purge and update. So here you can also do it at the fleet level in the main controller. So I'm just purging the update, purging and update application instances. And now I go to my nodes, to my fleet of devices, and I want basically to download the full configuration blob. So I can download it for these two nodes. And then I'm going to the EdgeSync UI locally. I will transfer it to the remote location and I will import it in the EdgeSync. And here you can see immediately that EdgeSync detected there are configuration updates for these two nodes, node 1 and node 2. And now I can select to which of the devices I want to apply the config. Okay. So I just apply the configuration to the one, and then you'll see in our metrics in our Grafana dashboard automatically that the application goes in halting state. So it's the device starts to process the application update. We see also the version number changing, so it means that it's a new version of our application. And then it will come online, and then we'll see that it becomes running. And you will also see the timestamp of the configuration updated in the EdgeSync, so the device properly processed our configuration update. And now if you go to the web UI, now I see Daniel, so welcome. So our application was actually updated, and we can do the same for the second device as well. So the same workflow. So the same metrics, we'll see the device reporting, the application halting. New version of our application is already being processed by the device, and now the application is running, and you'll get as well the same UI like we saw. So to conclude this, now the next is we'll just re-enable the connection into devices. So this is in the case, okay, if the device gets internet access again, so everything comes online in the controller, and we have a consistent deployment running in the field, right? So we see basically the operations that we can do in EdgeSync. So you can shut down the device, power off the device, reboot the device, or even collect info. And in the applications, you can restart an application or purge an application, right? So it's actually purge means to restore the application to its initial state. So now the moment where you're actually going to unlock the access to the internet, and then we'll see the application. Basically, the devices come online and there's no errors. Everything is fine in the main controller. Okay. I think that's it. Back to you, Daniel.
We're here. I'll jump in here. We are right at the top of the hour. So excellent timing on the presentations. Daniel, did you have anything else to add? That's last minute.
Yeah, let me just maybe wrap it, right? So as you saw in the demo from Sergio, the use case is, or the way he was interacting with it is intermittent connectivity. He re-enabled the connectivity, but this could have been like fully disconnected for extended amount of time or even forever, right? Like I think the main point is you need to, at day 0, like onboard, or day 1, you need to onboard on the cloud, and after that you can move it into a different environment and not have any connectivity anymore. So from a product perspective, EdgeSync is readily available. The UI will be available in October. So if you're interested in that, let us know. Then we obviously talked about those self-hosted type of scenarios. Those are a work in progress from our perspective. We're actually testing and co-developing with a few lead customers at the moment. So those initial use cases will actually be productized by the end of the year. Should you be interested in any of these scenarios, or maybe there's a shade of gray that we didn't dive into the details of, please reach out, right? There's a lot of things possible. There's a lot of shades of gray, how exactly you want things to be done, what can be done, what cannot be done. But we'd be more than happy to discussing your business needs in this disconnected environment or semi-disconnected environment, and ultimately provide an edge orchestration solution for fulfilling the requirements that you may have in your business. So reach out to us. Rob, that's it from my side. I don't know if we can still do Q&A for 1 or 2 minutes.
Yeah, there's a whole host of questions.
Not really.
See if we can get to at least a couple of them. For anybody who has to drop, totally understand. It's top of the hour. It's meeting time potentially, but we'll stick around just to make sure that a few of these questions get answered for you. And the first one is just a super quick one.
Okay.
Can we update EvoS with EdgeSync?
I should have seen that one coming. So today you can actually not. This has to do with remote attestation. So basically, when you upgrade EvoS, it changes the root partition, and there is PCR measurements for the root partition. There's work in progress on PCR policy, which basically allows you to ignore certain parts of the PCR measurement. That will effectively enable you to do exactly that. So yes, not today, but in the not so distant future, you will be able to do that.
Thanks. Next, how many devices can one EdgeSync manage? What is the scale of EdgeSync devices?
Yeah, I can take that one. So the target that we are qualifying the Edge Sync is currently between 15, 13 devices. So we see this the use case with 10, 15, but actually the target is up to 30 devices. So that's the qualifying target that we have in mind for Edge Sync.
Maybe I can add, right? Yeah. Like fundamentally, solution-wise, there's nothing that stops us to go beyond, like those 30 or 50 devices. If you want to do 100, you can do 100. Does it make sense to manage this transfer of configurations once you get to that kind of size? Operationally, I think that may not make such a huge amount of sense, and maybe it becomes a discussion on what you can do in a more on-prem style fashion. So somewhere there is a flip over from what is still like operationally sensible to do in this kind of model versus where does it start to make sense to have some kind of local controller infrastructure. So yeah, I mean, to Sergio's point, in the order of 30 devices, I think that makes a lot of sense for EdgeSync. It's too small to have something on-prem. Once that number gets bigger, like strictly speaking, there's no technical reason why you couldn't do EdgeSync. Whether it makes sense is another story.
Thank you. And anybody, if the question is not fully answered, please do enter your follow-up. Well, somebody's interested. How do I test it?
That's a good question. So as said, EdgeSync is readily available. The UI is coming in October. Yeah, depending on what you're interested in, I would say reach out to us. Reach out to the solution architects you may already be working with, or if you are not an existing Zadida customer, reach out to us, right? We'd be happy to talk, and we'll figure out a way for this to get into your hands ASAP. It's really around the corner, so if this is urgent on your end, we'll find a way to make it work.
Thank you. Question on configuration blobs. So this would be on the individual configs for the devices to be distributed by EdgeSync. I know you get Daniel and Sergio. I know you know that. Just for clarity for everyone, those configuration blobs, are they encrypted?
Sergio?
Yes. So actually, what I showed is actually when you download that bulk configuration blob. So it's basically a list, and we have the configuration blob encrypted for each device, right? So it is encrypted with the device certificate. So it's actually the controller signing that full JSON configuration of the device cert. And it's basically leveraging the multiple TLS infrastructure that you have between EvoS and our controller. So I didn't show in the demo, but if you just open that JSON file, it's just a bunch of characters that are encrypted and cannot be decoded by any means. Okay.
And maybe if I can add one more comment on that. I mean, the fact that it's encrypted or at least it should be signed, is it ensures that, I mean, we encrypt it, right? But at the bare minimum, you would have to sign it, because one of the things that we want to make sure is that when that configuration goes from, you know, the source towards some destination, that you cannot change it in flight, right? Like, you know, if you want to have a fleet management approach to dealing with this, you need to be able to rely on the fact that what actually got applied is also the thing that I sent out, right? And if this was just, you know, some YAML or JSON that anybody can just change a version or change some value and apply it, then obviously it wouldn't give you any guarantees that you're operating at a fleet level, that you're implementing the controls that you think that you have just implemented. So from our perspective, those configs are encrypted. You know, in theory, they could be just signed, but yeah, for sure, they will not be just open ASCII style configuration files that anybody can change, because it really changes what guarantees you have from a solution perspective.
Thank you. I think that was the answer everybody was expecting and hoping for, but just it's good to hear. Yeah. So the self-hosted solution, can you deliver that in Azure? I mean, and really, I'm going to extend that. Can we deliver that in GCP? Can we deliver that in AWS?
Yeah, so the on-prem, I mean, if you look at how infrastructure-wise we're building zCloud, it's a Kubernetes application. So in theory, as long as you have a Kubernetes environment, we can run zCloud. I mean, we do, from a solution tooling perspective, focus on some use cases, and Azure being one of them, by the way. So it's not so much of a technical thing in terms of what can you do. It's more a topic of, you know, what are you comfortable to support? What can you validate? What can you test? For what can you provide tools? So it's more in that space than, you know, a technical limitation of where can you do this. But our focus is Azure amongst one of them.
Thank you. I think we're on the very last one. I know we're like 10 minutes over. Thank you to all of you who are sticking around to hear this. So this one, you talked about how collecting debug information is available from EdgeSync. Does that apply to self-hosted solutions as well?
Yeah,
self-hosted. I'm assuming self-hosted Zadita Cloud.
Yeah, understood. Yeah, so Sergio talked about this collect info. So it's our mechanism of collecting logs and other statistics on a node. For those of you operating our system, you may be familiar with that. So in EdgeSync, you have a method of collecting that info and pushing it to some storage location, and then from there you can pass it on USB style or whatever other out-of-band mechanism you have to Zadita in this case. From a on-prem perspective, then obviously you have the full set of Zadita Cloud capabilities available to you, right? You're effectively running Zadita Cloud locally. So there, we actually have other means, probably easier means. We extended our Edge View capabilities in recent times with an ability to collect info TARs as well. So yeah, I mean, can you collect the same information? Yeah, 100%. Can you do it in the exact same way? Even that can be done. But given that you have full cloud capabilities available, there's actually a more convenient way through Edge View that you can pick up that information. So yeah, in that scenario, that's the way I would go.
Thank you. It looks like that's all of them.
Awesome.
I would invite anybody with further questions, please do email.
Yeah,
please do get in touch with us.
We're obviously more than happy to engage with anybody on any of these topics. If this is something that resonates with you, if you have a specific business problem you're trying to solve, reach out. We're here to discuss with you and find out, you know, what we can do for your business.
Fantastic. Well, thank you, Daniel. Thank you, Sergio. Thank you to everyone who attended. There will be a recording of this available in Zadita Edge Academy at academy.zadita.com. I'm Robert Bush for Edge Academy. Thank you so much. Look forward to seeing you in the next Zadita technical webinar. Enjoy the rest of your day or night, as the case may be.